A store owner wants to develop a new snack mix by mixing chocolate-covered raisins and trail mix. How many pounds of chocolate raisins, costing $11.20 per pound, should be mixed with 10 pounds of trail mix costing $6.34 per pound to create a mixture worth $8.50 per pound? The first thing we'll do is get organized using a 3x3 box. And generally speaking, when we're mixing grocery items together, the first two rows will be used to contain the info about the individual items that we're mixing together, and then the third row is going to be reserved for the information regarding the mixture. The column headers are going to be set up so that we're multiplying the first two columns together to get a product that is equal to the third column. And when we're mixing grocery items together, those column headers are going to be the price per pound of the grocery item multiplied by the number of pounds, and the product of those two things is going to give me the overall cost of that particular item. So we want to memorize this template and use it anytime we're mixing together grocery items. So now let's fit our specific scenario into this chart. And let's be a little more detailed about what those grocery items are. The first item is chocolate raisins. So let's just indicate that our first row is going to contain information about the raisins. And the second grocery item in the mixture is trail mix. So the second row contains the information about the trail mix. Now let's begin to populate the cells. The chocolate-covered raisins cost $11.20 per pound. So that's what's going to go into the price per pound cell in the raisins row. The trail mix costs $6.34 per pound. So we put that in the price per pound for the trail mix. We're also told that we want to create a mixture that's worth $8.50 per pound. So let's put $8.50 in the price per pound for the mixture. Now let's see if we can find what we need to put in this pounds column. Rereading the problem, we see the question, how many pounds of chocolate-covered raisins? Well, this is our unknown quantity, how many pounds? And the unknown quantity is what we want to assign the variable x to. So we don't know how many pounds of chocolate-covered raisins. But we are told how many pounds of trail mix. We're going to be mixing it with 10 pounds of trail mix, so we'll put 10 in the pound cell for the trail mix row. So if we start with 10 pounds of trail mix and we add x pounds of raisins, we're going to have a total of 10 plus x pounds of the mixture at the end. As far as the strategy is concerned, what we want to look out for are two completely populated columns. Once I have these first two columns populated, we can use those two columns to multiply across and generate the third column. So if we have x pounds of raisins that cost $11.20 per pound, then the total cost of the raisins is going to be x times $11.20. If we have 10 pounds of trail mix and each pound cost $6.34, then we're going to have 10 times $6.34 as the overall cost of the trail mix. And in the third row, if we multiply the price per pound by the number of pounds, then we're going to get the overall cost of the mixture. Once we have the cells of the table completely populated, this is when it's time to create a linear equation. And we can do that by adding the cost of the raisins to the cost of the trail mix, and the sum of those two costs is going to be the cost of the overall mixture. So essentially, what we're going to do is add the first two rows together to generate the third. So again, we'll have x times 1120. Let's rewrite that as 1120 times x, or even better, 11.2 times x. And we add that to 10 times 6.34. And the total of those two costs should equal the cost of the overall mixture, which is $8.50 times 10 plus x. So this is the linear equation that we now want to solve for x. To solve a linear equation, we simplify both sides as much as possible first. So we have 11.2x plus 10 times 6.34 is 63.4. And when we distribute 850 into the parentheses, we get 850 times 10, which is 85, plus 8.5 times x. Now let's subtract 63.4 from both sides to get our constant terms together. This yields 11.2 remaining on the left-hand side. 85 minus 63.4 is 21.6. And we still have our 8.5x. Now let's get our x terms together on the left-hand side. So we'll subtract 8.5x from both sides. The 8.5x's cancel on the right, and on the left we now have 2.7x's is equal to 21.6. To completely solve for x, we now need to divide both sides by 2.7. So they'll cancel out here on the left, leaving me with just x. And 21.6 divided by 2.7 on the right is 8. Now it's time to interpret this quantity and clearly state our answer. Remember, x was our unknown quantity that was given to the number of pounds of raisins. The question said, how many pounds of raisins are needed? We came up with our x value being 8, and this is how many pounds of raisins will be contained in the overall mixture.